Hello students. So today from the rest of the previous chapter we will start the reflection. We will start the topic of reflection. The chapter 1 of physics of class 10. Okay. So I have already told that reflection means bouncing back of light. Yes, reflection is the bouncing back of light. So we have discussed about the reflection through the plane mirrors. Okay, reflection through the plane surfaces. So about incident ray, reflected ray we have discussed. So light always travel. Already we know that light always travel in a straight path. Light travel in a straight path. So today we are going to discuss the topic of the spherical mirrors. Spherical mirrors. So what are the main two types of the spherical mirrors? First one is concave mirror, and second one is convex mirror. Concave mirror and convex mirror. Now what is the difference between the concave and convex mirror? Okay, they are spherical. It means that they are the part of a sphere. Okay, concave mirror is looking like this is termed as concave mirror. Means if you draw the whole arc, then it will be a sphere. Okay, this is only the part of a sphere. Clear? This is only the part of a sphere. It is called concave, and convex is this is convex. Clear? What is the difference? So this is the reflecting surface. This surface is the reflecting surface. Here, this surface is the reflecting surface. What is the difference between the two mirrors? In case of concave mirror, the reflecting surface is directed inwards, or you can say the reflecting surface in the middle of the reflecting surface, it is thinner as compared to the outer region. And in case of convex, the middle portion is thicker as compared to the outer region. Suppose this is the mirror. In case of plane, this is flat surface. Okay, in case of plane mirror, this is flat surface. In case of the concave mirror, the surface is like this. It is a curve directed inwards. And in case of convex mirror, the surface is like, the surface is flat. In middle, the surface is thicker. Clear? So these are the two difference between the different mirrors, concave and convex mirrors. Now we will discuss about the different positions of image in case of a concave or convex mirrors for a different position of the objects. Object means in our surroundings, any type of objects. Different things are maybe different objects. Okay. So first, so this is the concave mirror. This is the convex mirror. These are the reflecting surfaces. In case of convex, this is the reflecting surface. In case of concave, this is the reflecting surface. Clear? So these two parts are the part of a sphere. Clear? These two surfaces are the part of a sphere. So these are two spherical mirrors. This is concave, this is convex. So the midpoint of the mirrors are called pole. It is termed as P. It is pole. Now, if this is a part of a sphere, if you join the whole part, then it will be a sphere. So obviously it has a center. Okay, here if you draw by using the compass, say this is the compass, by using the compass, this will be the center. You can find the center easily. Or in case of this, the center will be behind the mirror. It is in front of the mirror. This is behind the mirror. In case of concave, the center is in front of the mirror. In case of convex, the center is behind the mirror. Now, this center is called center of curvature. Center of curvature, C. You have to imagine a line through C and P P. Through C and P, you have to imagine a line here also. Through C and P, you have to imagine a line. That line is called the line through C and P. Is called, it is principal axis. Okay, the line through C and P is called principal axis, and also the distance of CP is the radius. If it is a center, then it means that this is the radius. So the distance between the center and the pole is termed as, it is termed as radius of curvature. Curvature means this part. For this part, this is the center, and this distance is called radius of curvature. It is termed as capital R. It means R is equal CP. This is the distance of CP, which is denoted as capital R. Clear? Next, in case of this also, the CP is the radius of curvature. So in between the C and P on the principal axis, the midpoint of CP on the principal axis is called the focus point. It is also known as principal focus. Principal focus, which is termed as F. Same here, the midpoint of CP is called principal focus. Now we know that light travels. How can we define the principal focus? Yes, how can we define the principal focus? What is the definition of principal focus? So we know that light always travels in a straight path. Okay, light always travels in a straight path. So this is the front side of mirror. This is also the front side of mirror. So suppose at infinity there is some source. Means you can take the example of sun. There is some source at infinity. So from the infinity, if light travels, so light will falls on the mirror in the straight path. Straight path means the lines should be parallel with the principal axis. Always remember this. If light comes from infinity or from any object, light always falls on the mirror parallel to the principal axis. So in case of concave mirror, when light falls on the mirror, straight lines, light rays falls on the mirror, after reflection, it will passes through a point on the principal axis. Same, if you imagine a line here also, then after reflection it will passes through the point this. So now you can define. In case of concave mirror, the principal focus is if ray of light falls on the mirror from the infinity, which is parallel to the principal axis, after reflection they actually meet or intersect at a point which is on the principal axis. Yes, the line which are parallel, the light rays which are parallel with the principal axis, after reflection they will meet or intersect, actually meet or intersect at a point which is at the principal axis. That point, particular point, is called principal focus for the concave mirror. Clear? Also the mirror is known as converging. The mirror is known as converging mirror. Why it is called converging? Converging means to meet at somewhere. Yes, all the parallel rays. If you draw infinite number of parallel rays, all the rays after reflection they will meet at the focus point. All rays will converge. You can say after reflection they will converge to a point which is in the principal axis. That is called principal focus for the concave mirror. Okay. Now, in case of convex, same. If the parallel rays, the rays which is parallel to the principal axis, so these are two rays. Example of two rays. After reflection, it looks like they are diverge out from a point behind the mirror. It looks like the rays which are parallel with the principal axis, after reflection, it looks like they diverge out from a point behind the mirror on the principal axis. Diverge out means from a point which is behind the mirror, the rays will come out. Clear? That particular point is called focus. This is not the actual point, it is the imaginary point. Okay, so the definition is the rays which are parallel with the principal axis after reflection from the convex mirror, it looks like the reflected rays looks like diverges out from a point behind the mirror. That particular point is called principal focus of the convex mirror. Clear? So that difference between the mirror. Okay, you can see the difference between the mirrors here. The reflected rays actually meet at the point which is on the principal axis. That is called principal focus. But in case of convex, they actually don't meet at the focus. They looks like diverge out from a point. That point is called focus. That's why this mirror is also termed as diverging mirror. This mirror is also termed as diverging mirror. So this is the difference between the convex and the concave mirror. Clear? Now we will observe the different positions of the images in case of different positions of objects. Okay. Okay, now we will discuss the different rules. How can you draw the rays? Okay, if the ray coming parallel to the principal axis, then after reflection, by which part it will reflect in case of concave or convex? If a ray passes through focus, if a ray falls on the pole, if a ray passes through center of curvature, and what are the different paths of the reflected rays? Now we will see those things. There are 4 rules. Okay, so first one. So we will draw 4 rules. Number 1, 2, 3 and 4. First one, in case of concave. In case of concave mirror, this is the principal axis. Always remember, principal axis will passes through the midpoint of this mirror. And always remember, you have to draw the mirror by using the compass. Okay, first you take a point on the principal axis, then draw the mirror by using the compass. This is the pole. So here at some point it will focus, and double of focus will be the center of curvature. And remember one thing, the CP is radius. Okay, and focus, the distance between F and P, focus and pole, it is called focal length. It is called focal length, the distance between F and P. Clear? So FP distance, focal length. Now this distance is half of the radius. The F is the half of the radius. CP by 2, it means that R by 2. So you have to remember this formula. Focal length is always half of the radius of curvature. Clear? Now see, if a ray coming from infinity which is parallel to the principal axis, after reflection it will passes through the focus. This is the first rule. Remember, this mirror is the concave mirror. So the ray which is parallel with the principal axis, after reflection it will passes through the focus always. And in case of convex, you have to draw the principal axis. Here this will be the center of curvature. Okay, from here you can draw the mirror. This will be the focus. So if a ray parallel to the principal axis, what will happen? After reflection, the reflected ray will diverge out. Looks like diverge out from a point behind the mirror. This is the diagram. This is the rule. After reflection in case of convex, it will diverge out from a point behind the mirror. Clear? Now, second number. So this is concave mirror. So this is C and F, C, F, P. If a ray falls on the mirror, passes through the focus. If a ray falls on the mirror, passes through the focus, then after reflection it will reflect back parallel to the principal axis. The reflected ray, in case of the ray passes through the focus, incident ray, then the reflected ray will reflect back parallel to the principal axis. Reflected ray is parallel to the principal axis. It is inverse of this. Okay, in case of convex, this is focus, this is center of curvature. So if a ray looks like coming towards the focus, okay, looks like coming towards the focus, at this point after reflection it will reflect back, which is parallel with the principal axis. Clear? Third one. In case of concave, so this is center of curvature, this is F. So if a ray passes through the center of curvature, and hits the mirror, after reflection, interestingly, it will reflect back by the same path. It looks like the normal of the plane mirror. Okay, the normal in case of the plane mirror. In case of plane mirror, if a ray falls on the mirror through the normal, then it will reflect back by the same path. In case of spherical mirror also, if a ray passes through center of curvature, then after reflection it will reflect back by the same path. Clear? Now this. In case of convex, so this is focus, this is center of curvature. So here, if a ray looks like coming towards the C, towards the center of curvature, after reflection it will move back by the same path. It looks like coming towards the C, after reflection it will move back by the same path. Number 4. Focus, center of curvature in case of convex. Focus, center of curvature. So here this is the pole, it is related to pole. Okay, so if a ray, incident on the mirror at the pole directly falls on the pole, okay, by making some angle, so after reflection it will reflect back by making the same angle. Means this is the incident angle, this is the reflected angle. The two angles are always same. If an incident ray falls on the mirror by making an angle with the principal axis, then it will reflect back by making the same angle with the principal axis. Here, same in case of convex mirror also. These two angles are always same. These are the 4 rules by which you can draw the ray diagrams. Clear? Okay, next we will discuss some positions of the image. Okay, as related as if you can distinguish the position of the object, then you can find the position of the image. Okay, but before that we will discuss some sign convention. That means some laws. Say we know that images are of 2 types, real and virtual image. Clear? In case of concave or in case of convex mirror, so this is concave, this is convex mirror. The distance, okay, the distance which you travel towards left from the mirror, these distances are always negative. Okay, the distance which you travel towards left from the mirror are always negative. The distance which you travel towards right from the mirror are always positive. This is same for both the cases. The distance which you travel towards upwards are always positive and downwards are always negative. It is same as the Cartesian plan, means as coordinate geometry. Same as the coordinate geometry. So distance towards left is negative, distance toward right is positive from the mirror, okay, and distance upward from the principal axis positive, distance downward from the principal axis negative. Clear? Now why this type of distance are required. So you should know the positions of the image. Position of the image means the distance of the image. Suppose somewhere image is from here, somewhere behind the mirror. Clear? So what is the distance of the image from the mirror? You have to find out. So object is kept here. Then what is the distance of the object from the mirror? You have to find out. Okay. Okay. This we will discuss after we depict the positions of the images. So in the next class we will discuss the positions of image for the different positions of the object. Thank you.